Welcome to this explainer. Today we're taking a really fascinating micro to macro journey through the human nervous system. We're going to look closely at the hidden mechanics of your brain, starting right at the deeply personal level, how we learn and how we prep for peak performance, and then we're going to zoom all the way out to see how those exact same biological mechanisms actually build our social interactions and, surprisingly, our social biases. It's a lot of ground to cover, so let's get comfortable and break this all down.
All right, let's dive right in with a question that's probably crossed your mind at some point. Why does some kids, or even adults for that matter, just seem to remember everything, while the rest of us really struggle? I mean, we've all heard of things like a photographic memory, right? Where someone glances at a page and just retains it perfectly the next day. So is that purely an inherent hardwired trait, or is it a honed skill? Well, looking at the data, while there are absolutely inherent biological differences, just like how someone might naturally be a gifted dancer or have crazy good hand-eye coordination, that is really only one piece of the puzzle. The way those inherent capabilities are actually developed, that's what truly matters.
Section 1. The roots of faster learning. The biology and environment behind capability.
So to understand how our biological potential actually flourishes, we've got to look at this self-perpetuating learning loop. This is essentially how capability gets built. Step 1 is simply discovering an inherent talent. But it doesn't stop there, right? Step 2 is absolutely critical, feeling a positive reward and pleasure from doing that thing well. Think about it. When you're good at something, you get a psychological and biological reward. It literally feels good. And that leads us straight to step 3. You repeat and hone the skill. The minute you find something you excel at and it gives you that dopamine hit, you are naturally driven to do it over and over again, perfecting it along the way.
And this brings us to a brilliant thought experiment that shows what happens when we mess with that feedback loop. Imagine two identical twins. They've got the exact same biology, the exact same brain. Now, if you tell one kid every single day for a year that they are dumb and completely incapable of remembering things, and you tell the other kid every day that they're brilliant with a razor-sharp memory, what happens? Well, even with identical starting capabilities, the environment drives a massive differential. The continuous stress of being negated actually diminishes capability. But on the flip side, positive reinforcement actively builds and hones that memory. Basically, your environment acts as the crucial software running on your biological hardware.
Section 2. The brain's plasticity window, the biological timeline for nervous system change. Okay, so we've seen how the environment shapes learning, but here's the million-dollar question. Can adults change their brains the way kids can? The short answer is yes, but to a much lesser extent. The biological timeline really hinges on one magic number, 25. The first 25 years of your life represent this critical, highly active window where your nervous system is just incredibly open to change. Your brain is vastly more plastic. But what happens in the second 25 years, or the final 25? Well, it's essentially all downhill. The brain's plasticity reduces and actually moves in the opposite direction, which significantly limits the range of what it can effortlessly change. Now, just to anchor everything we're discussing today, let's quickly define plasticity. It's the ability of the brain to effectively change in response to the environment in order to adapt better to the world. That's it. Your brain's fundamental, full-time job is just taking in information from your surroundings and making physical and chemical changes to survive and thrive in that specific environment. Section 3. Peak performance and mental prep. How high achievers hack their biology. This brings us to one of the absolute coolest applications of neurobiology. If you observe thousands of Olympic athletes right before they hit the court or the track, you'll start to notice a common behavioral thread. Picture an Olympic runner sitting in the stands, just resting. Their 100-meter dash isn't up yet. They're just watching a completely different 400-meter race down on the track. But when the starting gun for that other race goes off, the runner up in the stands physically jerks. Their body involuntarily moves. Why? Because that gunshot isn't just scaring them, it's triggering an internal prep. That athlete has mentally practiced the running sequence so many times that it's become an automatic muscle memory reaction. Their brain is completely primed to fire the exact moment it hears that cue.
And what's really wild is that this predictive mental prep isn't just an athlete thing. It applies perfectly to other disciplines too, like music. Take a concert pianist. For them, individual fingers actually have distinct representations in the brain. So when they're about to play, even before they physically move a single finger, they imagine it. They literally start playing the sequence in a part of the brain called the premotor cortex. In fact, if a concert pianist is just sitting in the audience listening to someone else play a sequence they know, their brain starts producing the exact same sequence in their premotor cortex. They are mentally playing the music before a key is even struck.
So we can easily see how Olympic athletes and concert pianists use this mental prediction to perform at the highest levels. But how does this mental prep actually affect our everyday conversations? You might be thinking this is only for the elites, but the truth is, your brain is using this exact same predictive mechanism right now, every single day, in your normal social life.
Section 4. Mirror neurons and prediction. The shortcut for social interaction. Here's the secret. Our brains are not just reacting to the world around us. They are constantly, and I mean constantly, running these complex simulations of other people. And this simulation happens thanks to mirror neurons. This is a specialized prediction system highly developed in primates, and it allows us to imagine another person's actions and predict what they're going to do before they even do it. So if you and I are having a conversation, and I have a pretty good idea of how you're going to behave, the conversation flows effortlessly. Why? Because I'm basically mimicking your potential actions in my mind and predicting your next move. It is an amazing biological shortcut that makes complex social interactions manageable.
Section 5. The hidden cost of familiarity. How predictive ease turns into implicit bias.
Now, here is the real twist. While this prediction engine is a miracle of biology, it's also a massive double-edged sword that deeply shapes our society. See, when two people share a culture and a vocabulary, their interactions are a breeze because their mirror neurons can strongly predict the other's behavior. But what happens if you try to interact with someone from an entirely different culture, say someone from Indonesia who doesn't speak your language and doesn't share your cultural context? Well, the shortcut breaks. Your ability to predict their actions is just gone, and that leads to immediate interpersonal struggle. We naturally find it easier to hang out with our own demographic because our brains just don't have to work as hard to predict what's going to happen next. And frankly, this biological preference for ease directly drives implicit bias against those who are different.
To put it plainly, our brains just prefer people who sound, look, and behave like us. Why? Because they are easier to predict. The uncomfortable reality of this incredible mirror neuron system is that it makes it biologically harder to deal with individuals who act or sound very differently from our established norm. Our brains constantly want predictability to conserve energy and feel safe. So when someone breaks those established norms, it creates friction in the brain. Friction which then manifests in the real world as bias.
Which leaves us with a final, and I think incredibly important question. If our brains are essentially hardwired for bias just to ensure predictive survival, how can we use our neuroplasticity to rewrite the code? We know from earlier that our brains adapt to the environment. And sure, while it's harder after age 25, it is still entirely possible. So by intentionally putting ourselves in diverse environments and actively pushing through that initial interpersonal struggle, can we actually train our mirror neurons to predict a wider, more inclusive range of human behavior? It's a pretty fascinating thought to leave you with. Thank you so much for joining me for this explainer, and I hope this journey helped you understand the incredible hidden mechanics of your own mind.